All right, we're continuing section 8.1. We're getting our very last concept here. And that's when we have a perfect square in a variable that isn't a second power. So first of all, we want to be able to recognize that a perfect square for a variable means that the exponent is evenly divisible by 2. And finding the root is dividing the exponent by 2. So for our examples here, we have the square root of x to the 4th power. Well, the square root of x to the 4th power is taking this 4th power right here and dividing it by 2. And so the the square root of x to the 4th is x squared. And if you check that out, x squared squared, that would be the power rule, right? 2 times 2 is indeed 4. There it works. And so then the square root of x to the 12th would be 12 divided by 2, which would be x to the 6th. And you can check it out and see if it works, because you can square this, and that'd be the power rule, and 2 times 2 times 6 does indeed equal 12. So that's how you find the root when you don't have an x squared. All right, now let's apply that. So we have a binomial, we have a difference, and 16, we know that's a perfect square, right? But x to the 4th, is it a perfect square? Well, is it evenly divisible? Yep, and so therefore there's our root. And of course we know 81's a perfect square. So now we have 4x squared plus 9, and then we have 4x squared minus 9. Oh, but you know what? This just led to more factoring, because guess what? 4x squared plus 9 is again a binomial difference of squares. So we take the root here, so we get a 2 and x, and then here we get a 3. And that means that we can factor that one more time. So we have a 4x squared plus 9. Now, it's very much worth our while to mention that the sum of two perfect squares never factors. Sums of perfect squares do not factor. And then we have the sum of these and the difference of these, and that will be our final factorization. So when we say factor completely, we mean don't forget to keep going if we need to be. So 4x squared minus 9 is again a difference of two perfect squares, so we have to keep going. All right, now looking at our next problem here, we have an x to the 6th power. So we know 9's a perfect square, that's not a problem. But is x to the 6th? Sure it is, because it's divisible by 2, right? So that means we have an x cubed here. And the square root of y squared is y. And so we're going to have a 3x cubed, and we'll have a y. And again, another binomial with 3x cubed and a y, and then one's a plus and one's a minus. And we don't have to worry about that factoring further. That's not a perfect square. 3 is not evenly divisible by 2, so it's not a perfect square. 1's not divisible by 2, so it wouldn't be a perfect square either. So we're finished with that one. So now let me just pound home this point that I was making before. The sum of two squares does not factor. Okay, the only time that we could get any factoring to happen is if it had a GCF. So if there's no GCF, which we should always check for, then we would know it wouldn't factor. For example here, if I had 4x squared plus 9, obviously there's no GCF, and so it's not going to factor. And so if we can't factor something, remember that we write that this is prime. And so 4x squared plus 9 is a prime polynomial. And it does not factor because sums of perfect squares do not factor unless they have a GCF. And there is no GCF. All right, so that finishes 8.1.